Okay, so last time we used measure theory. So, measure theory. To be more precise, we used the Lebesgue measure, right? The measure theory and the Lebesgue measure, or Lebesgue measure. Lebesgue measure. And we defined the Lebesgue measure of some subset X, which we call to be an affection set, which is an abstraction of your affection for someone, to be the precise measure of affection. Okay? So we defined it to be that, and then we use some stuff, we try to prove some things there. Okay. So, that was the last video. Very cool. So you used, yep. So we used induction. So we considered the map psi of X to be equal to the piecewise map X plus infinity for X is equal to the supremum of our interval X, and X plus var epsilon for X that's sandwiched between the infimum of X and the supremum of X. But of course, it's not equal to the supremum of X itself. And I also restrict that. I also want to say that for the X in this second map over here, they won't ever get mapped onto the supremum of X. When we add epsilon to X, it will not become supremum of X. Okay? So X plus the epsilon will not become a supremum of X. So any X inside this interval over here, which is infimum of X and supremum of X, not included. So in this any Y inside this interval, for all Y inside this interval, Y plus epsilon will not equal the supremum of X. Okay? Of course, the supremum will become infinity, and no element plus epsilon will become infinity unless epsilon itself is infinity. But I also want to say that epsilon, or I already said that the epsilon is only part of the real numbers. It cannot possibly be infinity, because infinity is not part of the real numbers. It's part of the affine extended real numbers, but we did restrict epsilon to just R. Okay, so that was the last lecture. We proved by induction that this map is cute, and of course in the end we showed that, of course, by defining this map over here. Okay, so this is the global picture of the map. We just defined it to be named, which is the name of your crush. Okay, so that's what we did in the last lecture, and in today's lecture we will be taking a detour into modal theory. Modal logic. I think in the last lecture I said that we were gonna take a detour into calculus, but I feel like I want to do the modal logic one first, because the modal logic one is a very I did an overhaul on the proof. In the first iteration of the proof for the theorem, it was actually only me showing that it's a contingent truth. But what we want to show is that it is a necessary truth, right? So yeah. The problem with the last proof of this theorem in modal logic is that it was only contingent. All I did was show it's a contingent truth, because I said that since it works for our base world, it works for other base worlds, but we can't construct a possible world wherein your crush is not cute, or the proposition is false. Okay, so here, in this lecture, we will be using Kurt Godel's ontological argument. So, Kurt Godel's ontological argument. To be more precise, we're going to be using Kurt Godel's ontological argument for the proof of God. But we're not really going to be going much into religion today. We're not going to try to prove that God exists. All we want to do is modify the argument in order to show that there exists a singular cute person, or a cute person that contains all cute properties, and we define that cute person to be your crush. Okay? So that's our argument. Or yeah, I know this isn't much of a proof, but it's more of an argument. So take note of that for today. So Kurt Gödel's ontological argument. So Kurt Gödel was a mathematician back in the 20th century, who proposed one of the most groundbreaking, I mean not really groundbreaking, but earth-shattering theorems in modern mathematics, which is the incompleteness theorem. And it showed that any axiomatic system that we can construct cannot fully decide the truth of some facts. So, such as the axioms of Euclid, the Euclidean axioms about geometry, the basic ones. There is a fourth one. There is an axiom there that we can neither show to be true self-evidently or not. Alright? And stuff like the collapse conjecture is an example of the shortcomings of math, because right now, even though it's extremely simple, we can't prove it yet. Or we can't prove that any number we put in there, whether odd or even, lets the entire algorithm converge to 1. We can't explain why it does that. Okay? Alright. So what I'm first going to do is explain the entire proof, and then I'm going to give you guys the symbol version of the proof. Okay? So yeah. So let's start with axiom 1. So we have to lay down a bunch of axioms. And first let's begin with, I'm going to first explain what are the symbols involved. So var phi denotes a property. So what is a property? A property is basically something that an object possesses, like a property. It's an intuitive thing, right? So a property of this marker is that it's shaped like, or this object here is that it's shaped like a marker, or it has a black cap. That's a property of it, right? The shirt I'm wearing is green. That's a property of the shirt I'm wearing. Okay, so yeah. So let var phi denote a property, and also psi. So let these two denote a property. So they're not maps or anything right now. All they are things that describe an object, or certain adjectives or things that an object possesses. Okay. And so I'll denote a property that's called cute is denoted by this over here. I know this is not a function or a map. What this simply means is that the property is cute. So it's a cute property. That's all we want to know. Okay? And I have a third object that I wanna call, which is CUTE of X. Okay, so here's the thing. X here is an object. So it's an object, it's a thing, it's an object, not really a property. But C over here, this C of var phi is defined over properties only. But cute over here, cute of X, is only defined over objects X. Now, I need to clarify to you guys first that although I am calling X here an object, I am not treating your crush, who is a human being, as an object, okay? What we're simply trying to do with this proof is show that there is an entity, you could say, an entity or an object that is extremely cute, that contains all the cute properties. And so, yeah. So like how Kurt Godel showed that, or defined God to be all things good, right? And then prove that there's such an object using some fundamental axioms. We will do the same thing here. Actually, it's an exact copy of the argument, but we just switched the good part with cute, and of course God with your crush. Okay, so just need to note, sign var phi are properties. This cute of phi is simply saying that the property is cute and is only defined over properties, and this cute is defined over objects. However, I can also, in the middle of the proof, I will say that this here is sort of suddenly defined over this thing over here, this proposition or something, or this entity or an object. So this is technically an object, this proposition over here, okay? So the real goal of the argument today is to show a necessary truth, okay? So we will show that there necessarily exists a Qt object, which is your crush, okay? So let's start with axiom 1. If var phi is Qt, so C of var phi, and var phi forces psi, and what I mean by forces psi is that if I have an object S that has property phi, it must, property psi, it must have property phi. Yeah, if it has property psi, phi, it must have property psi. Okay. If that's the case, psi is Qt. Okay, so that's our first axiom. So what I mean by var phi forces psi, if I have an object X or an entity X that contains or that possesses the property, var phi, let's say my shirt is green, let's say that my shirt being green is Qt, right? And if it forces psi, so that means, let's say that psi is my shirt, let's say upper garment, okay, my upper garment is green and it is a shirt, okay. So then it must be that something being a shirt is Qt, okay. So if something red is if an upper garment is green, right, and being green is Qt, and my upper garment is a shirt, then it must be that green shirts are Qt. Okay, so that's something. So it's a shirt and it's an upper garment, and because I'm saying that one is Qt, and then the object is that contains the property is Qt, and I have another property inside that object has, that other property must be Qt. That's what I mean. What I mean by forces here is that it transfers. So the Qtness transfers. Okay. Okay, that's axiom 1. Axiom 2. Alright. For every property var phi, either var phi or its negation is Qt. Okay. For every property var phi, either, okay, I'll just write it in words. Either var phi or the negation of var phi is Qt. So the second axiom tells me that a shirt that's green can be and cannot be Qt. Okay, so it's possible that it contains this property, or it's possible that a shirt that's green is Qt, or something being green is Qt. Okay, that's just a property. It's not an object having a property. Any object that's green or any object that is not green can be Qt. Okay, that's what axiom 2 is saying. And of course, these are just examples. You can plug it in for any other property you can think of. Okay. Okay. Now here's a caveat. So I'll erase this. Put a star. Okay, use a star. All right. If this one here is Qt, if the negation of phi is Qt, so green shirt not being green, if a green object is Qt, or an object that isn't green is Qt, then we may say that a shirt being green or var phi is anti-Qt. Called quote unquote anti-Qt or ugly, because I kind of want to avoid the word ugly, because I don't want to imply that some properties are ugly, because there's really no properties that are ugly. Okay, so if I say that all shirts that are green are Qt, then we say that all shirts that are green are ugly. Okay, that's that's what I mean by this caveat here. Alright, axiom 2. Alright. Theorem 1. So now that we have our two axioms here, theorem 1. Which is named good things can happen, but we're renaming it to cute things can happen. Okay, so theorem 1, if a property phi is cute, then it is possible. That something exists with property phi. There exists something with phi. Okay, so proof. Of course, a theorem requires a proof. Let's prove it. Okay, so suppose var phi, okay, is cute, but it's necessary, so box, that that there does not exist something with P. Oh no, phi, sorry, not P. So there exists something that it's necessary that there exists something with there does not exist something. So it must be that we're assuming that there exists no object that has property var phi. Okay. Then, because of that, var phi would force, okay, it will force every other property. Okay, which includes the negation. Which includes its negation. So, namely, var phi forces its negation. All right. And since according to axiom 2, axiom 1, if an object has var phi and it forces its negation, that means it must have its negation. But that doesn't make sense. Okay, if an object here is green, let's say, if it's green, if the shirt is green, then according to axiom 1 and according to our assumption that there does not exist something with phi, it must be that the object is also not green. So it must have the property that it isn't green, which is a contradiction because it already is green. And likewise, if I force its negation, then it must be that, okay, it is not green, but since it forces it because of our assumption in the beginning of the proof, then it must be that it is also green, even though we said it isn't green, because we said it's negation or assumed it's negation. So we have a contradiction. So it's a proof by contradiction. Because by axiom 1, var phi is cute. Yeah? So a property is cute. And its negation would imply, of course, not cute. So something is cute when it is not cute, which is a contradiction. So that's the proof. I'm not going to completely write the proof anymore. Okay, so there. That's that. Alright, so that's theorem 1. Theorem 1. Next, a definition. So we only arrive with definite arguments when we put up definitions, not just axioms. And also, I must state that the problem with this proof, okay, no matter how concrete it is, and no matter how good it is right now, how good it seems to you, there's the problem of modal collapse. Because as soon as we say that this proof holds according to the axioms, of course, I mean, it's all dependent on the axioms. whether a certain theorem is right to you. Okay, you can reject some of the axioms and say, oh well, that's not true, even though it sort of looks evidently true, right? Or you can't just claim that. Of course, you can say that, and you can probably object to my proof by looking meticulously at the axioms and the definitions I lay out. But the real problem with this restructure or renaming or relabeling of the ontological argument is that it introduces something called a modal collapse. Okay, and a modal collapse is wherein every contingent truth is necessarily true. Okay, so all right, in the end of the proof, I will say that there must exist an object that contains all the cuteness, which is your crush, not an object but an entity. But because we agree to some of those terms, it implies some other possible world which is necessarily true, or which laws or derivations are necessarily true. And we did derive in that world that there does not exist, because we're a bunch of pessimists and very negative people in that world. We did derive the result that your crush is not cute. And because of our modal collapse, it's necessary that that is true, even though we already proved that your crush being cute, or that one entity exists, right? And it's true. So that means there are two necessary truths that are contradicting each other, which we don't want. But that's the risk with using this proof, okay? So unlike the other ones where they are already structured on a solid basis, like group theory and stuff like that, we started off with a bunch of definitions and then we layered stuff from there. Of course, and also in measure theory. Here, there's a modal collapse is the singular problem that will plague this proof, and it's up to you guys whether you want to accept the proof or not because of this. Okay. So B1. Okay. So continuing, definition 1. So I'm just gonna write def 1. Okay. We call something cute when it has every possible cute property. So, we call a something. So X is a something. When it has all cute properties. Okay, so that's our definition. So in this definition, Kurt Godel originally said that an object or something, that a something is godlike, right? A something is godlike when it has all the good properties, when it has all the good stuff in it, right? I mean, don't you think that that's what God should be defined as? All things good. But here we repurposed it and said that a something that is cute contains all the cute properties, right? Like being fluffy, having pastel colors, like your cat, something like that. Okay. So yeah, and this all holds despite the subjective definition of what it means to be cute, because this property ranges over every possible property that you think is cute. So C here, C of phi, is every cute possibly cute property that you can think of, or dependent on how you think something's cute. So this entire thing can stand up to subjective things, unlike our other proofs wherein it's all objective and we threw out the subjective meaning out into the wind. Okay. So definition 1. So after we introduce this definition, let's introduce another axiom. This is axiom 3. And this is, it's cute to be cute. I mean, how can... Okay. So a something X is cute when it is cute, right? So a property that is cute is also cute, right? A property that is being cute or that is cute is cute. How can you deny this axiom? It's certainly true that when something is something, it is that something, right? If the cap of this marker is black, then the cap is black. There's nothing else that you guys can say about this. I mean, You guys can think that is white if you have an inverted mind, but ultimately it is black, and it is black alone. Okay? So axiom 3, being it's cute to be cute. Okay, so using these, let's make another theorem. So theorem number 2, which is called no atheism, and the original proof that Kurt Godel made. But here we will call it no anti-cuteness. So it's possible. So it's possible that something cute exists. All right. So we're not diving into negativity here, but we want this theorem here. So it's possible that something cute exists. That something cute exists. We're not a bunch of negative assholes here. We do want to prove in the end that your crush is cute, and so it requires us to state this theorem over here and thus prove it. And you can't deny this because we're using logic here, something that we intrinsically know from our youth here. So yeah, well, that is if you accept the axioms. So I'm not going to write the proof anymore because theorem 2 holds when we apply theorem 1 to axiom 3. So recall again that theorem 1 is if some var phi is cute, then it is possible that something exists with that property. Okay, and so I just apply that theorem. I just apply that theorem on axiom 3 because it's possible that something with a cute property exists, and you know it's cute to be cute. Then that object is cute. All right, so we're following logically. Okay, so I stated in theorem number 1 that it's possible that something exists with a cute property, and because it is cute to be cute, and that object has that cute property, that possible object contains that possible that thing, then that something is cute, or that possible something is cute, and it's likely it's and rephrase it a bit and say it's possible that something cute exists. Okay, so that's theorem 2. All right, definition 2. We call phi, a property phi, the essence of an entity or object X when 1, so there are 2 things it must strike. X has property phi, X has phi, and 2, property phi, so phi forces all other properties of X. Okay? So every other properties of X, phi forces. And I believe that this is where the modal collapse might happen, or is implied to happen, because every possible other property of X essentially becomes assimilated by var phi. Yeah. And so you can sort of see how that sort of breaks things down. Directly there. I don't know, maybe it could be from some other part of the proof, but for me right now, this is what seems to be the culprit, and why people say that this entire argument introduces a modal collapse. Alright, so definition 2. Alright, and let's introduce a 4th axiom, axiom 4. And we are shockingly close to the end of the proof. Axiom 4. If var phi is cute, then var phi is necessarily cute. Okay. So if var phi is cute, then it is necessarily cute. Obviously, if an object is something, it is necessarily that thing, right? And yeah, And actually no, it's not just 2 that sort of implies a modal collapse. It's this axiom here that introduces a modal collapse. Because, you know, we're saying that in any other possible world, that object stays cute, or that property stays cute, right? So likewise here, in my marker, it's possible, there's a possible world wherein it is black. There's a possibility that my shirt in another world is actually white, like in my other videos, right? And we're asserting with this axiom that in all those other possible worlds, the property holds, that this remains black and this remains green. So yeah, because of that, we can imply that any other object with another property must have the property in other possible worlds. And I think that's the real culprit of the modal collapse. All right. So axiom 4. If a property var is cute, then it's necessarily cute. So let's do a brief rundown of all of these. Definition 1, we call an object or entity X cute when it has all the cute properties out there. Okay? That's why I keep mentioning in the beginning. Axiom 3, it's cute to be cute. So if an object has a cute property or is cute from definition 1, then it is cute in itself. Okay, theorem 2, it's possible that something cute exists, and the proof of that theorem is we only applied theorem 1 on axiom 3. And theorem 1, of course, again, if theorem 1, if var phi is cute, property is cute, then it is possible that something exists with that property. And because there's that possible, or that thing that might exist that contains var phi exists, it's possible that it exists, then that it has a cute property, then it must be cute according to axiom 3. Okay. Next, definition 2, we call var phi the essence of X, the essence of X, when 1, X has var phi, and 2, var phi forces all other properties of X. So it assimilates all other properties of X. Or we say that all properties of X are possibly cute as well. Okay? If var phi is cute, then it's necessarily cute. Okay, so in all possible worlds we can construct, var phi remains cute, or the property remains cute. Okay. So there. Next, another theorem. Theorem 3. In total, there are 4 theorems, 5 axioms, and 3 definitions. Okay. So this may take a little while. This may stretch up to 40 or 50 minutes. Maybe even an hour, but hopefully not that long. Okay, so theorem 3. I'm just gonna write THM3. Okay? If a thing is cute, then being cute is its essence. And you know, an essence in this sense doesn't necessarily mean the real purpose of the thing. So when I say that, of course, your crush is cute and being cute is his or her essence or their essence, I'm not necessarily saying that that's the only purpose they have in life, to be cute, and that they have no other aspirations or things like that. What I'm saying is that it's the property that they contain. That's all. Oop. All right. Alright, so proof. So first note that if our entity X is cute, it has all cute properties. You know, by our by definition 1. By definition 1, if an X or if a something X is cute, then it contains all the cute properties. Right? Alright. So. And of course, no ugly properties exist via axiom 2, because of course we say it contains all the cute properties, and it can't possibly contain ugly properties because it only contains cute properties. Okay, so any property a cute object has is cute, and is therefore necessarily cute by axiom 4, right? And is therefore necessarily held by anything that's cute. All right. So let's do that again. Okay. Proof if cute of x. So when we say cute of x, we're saying that the object or entity x is cute. Right? Cute. It has all. So it has all. It has all C of var phi. By definition, it has all the cube. Definition 1. Yeah, by definition 1. It has all. Yeah. Okay. And it has no negation C of var phi. So no ugly objects. That's why I want you guys to notice. All right. So because of this, any property. So any property. So any var phi. Cute x has is cute. Right? So every property it has is cute and is therefore necessarily cute. Via axiom 4. Which states that anything that is cute, right? It's cute to be cute, right? Because we've already asserted that x here is cute, then it's necessarily cute via axiom 4, all right? The sort of culprit as to the modal collapse. And none of anything here I've said is pulled from things outside what we've already written. So I'm not pulling any invisible assumptions or stuff like that. I mean, Kurt Godel did, and I'm probably doing that as well. But right now, what I'm saying is that this is a self-contained proof, and everything that we have came up with up to this point has been a result of applying rigorous logic on facts that we have established at the start, or axioms that we have laid down, fundamental assumptions that are self-evidently true. All right. So it's necessarily cute and is therefore necessarily held by anything cute. Necessarily held. So any cute thing, cute something x. So that's cool. So shaded box, or you could write there QED quadratem is random. So and proof of theorem 3. All right. So here's the last stretch. Last definition, axiom, and theorem, right? And yeah, we will have a result. So we need to define indispensability of something. All right. So definition 3. We call a something indispensable. I can't spell. Indispensable. All right. When something with its essence must exist. I mean, and that is if it has an essence. So in the original argument, what we mean to say here in this definition is that we're calling God indispensable, or that God-like object indispensable, because its essence is being good, right? And there do exist people. There always exist people that are good. So therefore, it is indispensable. Right? That's what the definition is saying. We're calling God, or that godlike being, indispensable because people contain its essence, which is being good. Right? And likewise, we call a cute object, indispensable because when there's another thing that also contains its cuteness. Right. Alright, so axiom, last axiom of this lecture. Axiom 5, being indispensable is cute. So being indispensable is cute. So indispensability is a property that an object exists when it is necessary that something else with its essence exists. And now we're saying that property of being indispensable is cute. Right? And I will denote indispensability of something as E of X. So E of X. This denotes indispensability of an object. Okay? Alright, the home stretch, the thing you all have been waiting for, Theorem 4. In this argument, okay, not in the entire literature or of the paper or our theory. So Theorem 4, something cute exists. Something cute exists. It's necessary that something cute exists, which is so just replace them with your crush's name. Alright? So proof. Alright, this proof is gonna be a bit heavy. If something is cute, it has all cute properties by definition. Okay? It's established. Alright. If X is cute, then X has all C of phi by definition. Alright? So namely, it's indispensable. So cute X is indispensable. Alright? Since it has a cute property. Since it has a C of bar 5. So it has a cute property by axiom 5. So by definition, something with its essence, which is just being cute, by theory, previous theorem, must exist. So by definition, there must exist something with its essence, with this cute property, which is its essence, must exist. In other words, if something cute exists, it's necessary something cute exists. Now what I'm saying here is that because there's a certain thing, let's say a dog or a cute that's cute, then there must also exist another very cute person or entity, which is your crush, right? That's what this proof is saying. So there's an alternate version of this theorem. In other words, if something, okay. However, by theorem 2, it's possible that something cute exists. So it's possible that it's necessary for something cute to exist. And so it is, in fact, necessary for something cute to exist. You can also use a double line here instead of a box, so you don't confuse it with necessary. Right? So there. So now that we have stated the entire proof, so what theorem 4 is basically saying is that there should exist that because of all the things we've done, or all the things we've established thus far. Now let's put it in symbols. Now I'm not gonna write down the proofs anymore, but for those the nerdy ones are among you who wants to see the symbol version of all of this. All right, so wrong paper. All right, so axiom 1, which I'm just gonna write axiom 1. C of phi or phi, and it's necessary that for all x var phi forces psi of x then C of psi. So psi is cubed. Axiom 1. So axiom 2, C of the negation of var phi. If and only if negation of C of phi. So it's one of these can be true. Okay, theorem 1. C of var phi implies that it's possible that there exists an x that contains this property. So var phi of x means that x satisfies that property. Or by satisfies, I mean it has that property. Okay. 1. Definition 2. Oh wait, definition 1. Sorry. So cute, we call an object cute, or something, an entity cute, if and only if, for all var phi that is cute, x contains that, or x satisfies that property. Okay, so definition 1. Oh, by the way, all of this employs first order logic notation. Okay. And modal logic, like diamond for possibly and square for necessarily. Okay. Axiom 3. It's cute to be cute. Okay. Axiom 3. Theorem 2. It's possible that there exists an x that is cute. Because of theorem 1 applied on axiom 3. That's theorem 2. So definition 2. We call var phi the essence of x if and only if var phi of x, and for all, or x satisfies var phi, or has x, or x has the property var phi, and for all psi, for all properties psi of x, that of x, it becomes necessary that for all y, var phi of y is forced into psi of y. Parenthesis. Alright, so that's definition 2. Axiom 4. So C of var phi, C of var phi implies that it's necessary that C of var phi. It's necessary that if a property is cute, it's necessary that it is cute. Okay. Axiom 4. Theorem 3. So cute, object that's cute or something, entity is cute, implies that cute is the essence of x. By definition 2. in definition 3, which is the indispensability, and the thing I told you guys a while ago, denoted by U of X. An object is indispensable if and only if, for all var phi is the essence of X. So var phi being the essence of X implies that it's necessary that for all Y, var phi or Y satisfies var phi. Okay, that's definition 3. Axiom 5. C. So it's Q to be indispensable, by which is U being Q because any other possible, because there exists another object that is Q as well, or that has a Q property. Okay. So 5, and then lastly theorem 4. It's necessary that there exists an X is cute that satisfies this property, which is X defined to be name, which in the original proof, of course, is defined to be God itself, the Almighty G. But here it's of course name, and it's cute. So what I want to distinguish is that, unlike functional notation here, right? Instead of thinking of every object that we put into f of x, our function or our map, here, what we're saying is that every x that's inside, or that we could possibly put inside this quote-unquote function, satisfies it. So what we mean by this symbol here is x is indispensable, or x is e, and here var phi is cute. All right, so you read this as var phi is cute instead of cute of var phi. It doesn't make sense, right? And here, of course, as we said in axiom 3 physically, it's cute to be cute. So here's the symbol version of all of these. All right. In definition 3, var phi of y, so y is any other object, right? And so we're just saying that var phi being the essence of x means that there exists, or it must be that there exists other somethings y that satisfies, that also has var phi. So in the case of an object having var phi, like var phi of x, instead we say that x has var phi. So if var phi is a property, read this var phi of x has var phi. So okay, so let me summarize what I just said. If I have something like indispensability here, or an object, so I have a property of an object, such as indispensability, we read this as x is, and then that property, which is indispensable. If I have something like var phi over here, which is another property, but it's not indispensability, we say that x has that property. Well, you could say that x has the property of indispensability, but we can just say x is indispensable. But here we're generalizing it into any other property which we deem to be cute. So yeah. And so over here, if I have cute over, or I have a certain property that is another property, like say it is cute, then we just say that var phi is cute for this symbol here. So there. So that's it for this lecture. And in the next one, I swear, the next one will be the calculus one, or you could call it real analysis. So yeah, it's going to be a short one, and then after that, I believe we're going to go dive into the topology section, which will be one big lecture already, which involves homotopies. Right? So as mentioned in the paper, and also lemon surfaces, because of course eyes, and you guys can make the analogy from that. So this is a good place to stop.